Hello, hey everyone, welcome to Sleepy Radiology classes. And I promise it will be easy for you.
Hello everyone, welcome back to Sleepy Radiology classes, and today we are day 6 of QA series. This is Survey here. Today we are going to discuss about the 3 tests, and they are very easy tests in diagnostic radiological field. That is timer accuracy test, applied KVP, or sometimes we call it as accuracy of tube potential or tube voltage, and leakage radiation test. So let's move on to the first test of the day, that is timer accuracy or timer checking test. So timer accuracy means that we are setting like example 0.6 second. So whether we are getting same as 0.6 second, so that becomes a question when we are buying referred based machines. So that is a test, that is timer checking, will give you the information about whether your tube is giving us the actual time which we are setting or not. So this also is very useful in diagnostic level to optimize the level of doses, and also it helps the radiographer to minimize whether our dose is overexposed or underexposed. So that thing also you have to keep in mind, and this test is done very periodically in the range of once in a 3 month, and basically we use the spinning top for this test, and also we use something called as Wilkinson test. So to check the timer accuracy, we require a special device that is called a spinning top or Wilson coin tool. So we will just talk about the most used device, that is the spinning top, and this is a motorized system at the top, and this top is made up of brass and it has a small hole. So this top during the exposure is allowed to rotate, and we record with how much the time the film requires to expose. So you can see here, this is a spinning top device which we are using mainly for the timer check purpose. Next, straightway moving to the procedure. First thing is we have to adjust the height, and the height will be adjusted to 100 cm SID. Next, you are going to adjust the KVP within the range of 60 to 70 and MAS, that is 40 to 80 second. And you can do the test for 2 types, one for applied voltage of 0.4 second, another for applied voltage of 0.8 second. The next thing is you will on the exposure, and just with the help of, there is one foot pedal, once you press it, the spinning top tries to move. So that once you are exposing, you have to keep in mind that shoot and press will be same time. Then you can record that for 70 kV how much time it took, for 80 kV how much time it took, how many numbers of points you can see, how many numbers of slit patterns you can see, what is the number of arc, and all these things should not cross the tolerance value of 10%. So now everything is motorized. So now how we can do is, we will just put like a timer checker, we have to find is number of density patterns on the film. So you can see in the image it is mentioned for each rotation how much second it required by pulse frequency. So if it is a single pulse, it will be 1 by 50. If it is full wave rectifier we are using, then it will be 1 by 100, so on we have to do the calculation. And our degree of angulation is, if we are using arc, is 360 degree. So that thing you have to keep in mind. So next in the image you can see, this is how we are recording the images on the film. So how many arcs you see, that is the number of exposures you have received, and that is the time required for each exposure. So you can also record whether it is high exposed, it is okay, or it is overexposed. So, this thing also you can see in the image. So that was all about the timer check, and its accuracy should not be more than 10%. So after the timer check, we will just move directly towards our tube voltage or accuracy of tube potential. So why it is required? We all know that applied KVP, that is kilo voltage, will affect the quality as well as quantity of X-ray which is reaching to the film or our image receptor. So if we don't do the test, it will affect the quality and quantity of X-ray, that is it will create an effect on the contrast and density on the radiograph. So that is very much necessary that to check what happens when we are setting at KVP at various levels, like 60 kb if you are giving, what happens when you are giving 70 kV, what happens once you are giving 80 kV, what happens to the image film. So that by this we can record whether at 60 kV whether our film is, or whether our area is overexposed or underexposed, or at 80 kV whether we are getting overexposed or underexposed. So all these things, informations you can get with the help of tube potential, and this test is done with the help of KVP meter. So this test is done once in a 3 years, and this is the one of the QA which is done after a long duration of time, and once in a 3 year we check whether our tube is giving us the exact KVP and our image is not getting overexposed or underexposed. So to do this test we require a device that is called as KVP meter, and this KVP meter consists of two solid state detectors of different beam hardening filter who records our radiation doses, and the accuracy and the tolerance value of this test should not cross plus minus 5 kb. It may be in the range of minus 5 kb or plus 5 kb, but it should not exceed more than that. So to do this test, just the one thing is that you have to adjust the height to 40 to 50 centimeter, and next is you have to put the KVP meter tool, and next you also require the ionization chamber or pocket dosimeter to record the doses. Next thing is just do one thing is you have to adjust a fixed kb 60 kb, and you have to take one at high MAS and another at low MAS. So this will give you the reading that in what range of MAS your machine is giving you the perfect image. Like this you will simultaneously do for 80 kb, 100 kb and so on, using one high MAS value, one low MAS value, and also you can use a mid MAS value, and you will record all the images. The main purpose is that if a company is saying you that it is giving 60 kb, whether it is giving 60 kb or not, we have to check it in applied KVP. This is one sample format. The thing is just we will expose them at various kV levels, and we will just record that I have set 60 kb, whether I am getting it as 60 kb or not, and at what range of kb it is giving the image, and what is the MAS. So that is all about my applied tube voltage test. So next we are moving all to last QA for the day, that is tube house leakage test. And we all know that leakage radiation is very much dangerous if it is not kept within the limit. So leakage radiation is produced in all the ionizing radiation areas, and to measure this leakage radiation we are using the survey meters, or you can use the GM counter meters. So the main purpose of leakage radiation is to check that the leakage radiation which is coming out from the tube is within the permissible limit, and it won't cause any harmful effect to the stuffs. So if there is any leakage within the tube, immediately repair it so that it won't give the excess dose to the stuffs. Next thing, mainly the leakage radiation which increases is like we are continuously moving the tube in multiple direction. So inside the tube housing there we have the light stripes. So these stripes are like small panels. So what happens is, due to continuous movement, these panels collide from their places and creates a vacant space, which allows the radiation to come out more than is permissible limit. So what the thing they do is they just open the tube housing, they adjust the panels, and again it is rectified and one QA is done. So now the main question is, when we do actually the leakage radiation test, we actually do it periodically to record the doses in the area, and mainly we do it during the installation of the machine, after the installation of the machine, once we repair any machine, after the repairment of the machine. So I hope it is clear now. So let's move on to the device which we use mainly to measure the leakage radiation. So to measure the leakage radiation, mainly we require is the radiation survey meter. So what are the radiation survey meters we have? We have ionization chamber, we have GM counter. You can see this is a GM counter. And when we are doing the test, we should always keep in mind that we'll place the GM counter at 1 meter distance and from the tube and collimator. One we will take with collimator open, another we will take with collimator close. So this is, you can see here, the GM counter, and we will measure it from all the side, cathode side, anode side, top, bottom. Okay, next, so first thing is, when you are doing the leakage radiation, one you will do with maximum kVp, another you will do with the minimum kVp. So this will be very much useful, that when I am lowering the kVp, how much is my leakage radiation, whether it is in my permissible limit or not, when I am hiring the kVp, whether it is high or not. Okay, next thing is, you will adjust the kVp. Done, everything is done. Now what we will do is, we will go and we will first, one person will be standing in the control panel. There you will record 2 manpower, another person will come with the GM counter. So first you adjust the high exposure limits, like high kVp, high MAS. Next is shoot first, then record from anode side, shoot again, record from cathode side, shoot, record from top, shoot, record from below, shoot, record from front, shoot, record from back, and record all the images all the readings in the chart. And you should always keep in mind that its tolerance value should not exceed 1 meter radiation from focus more than 115 milliroentgen in 1 hour. That is, at least 180 milliroentgen per hour is the permissible limit. So that was all about our QA session 6, and we have discussed about timer checking, applied KVP and tube leakage radiation. So and the last, you have to also keep in mind that all the calculations are done on these units. We all know about the units. If you don't know, we have placed the link below, you can check it. And finally, we have only one QA left, that is the total filtration test, which we will be doing in next coming days. So keep tuned, keep subscribe, like it and more share. Thank you so much.